Hello and welcome to the section 11.3 lecture today for Algebra 1 Part 2. Today we're going to be talking about scientific notation, writing numbers in scientific notation, writing numbers in standard notation from scientific, and even some plus minus times divide types of problems. With this first little thing here, the let's play a game, I actually want to save that for class because it's kind of interesting and I want everybody to experience it in class. So be ready for that tomorrow. If you want to start thinking about it, feel free, but I'm going to expose the answer tomorrow. But it does say I want to save money to buy a special gift for Brittany, birthday gift. My plan is to start saving on February 1st and buy the gift at the end of March for her mid-April birthday. And it says that on February 1st, I'm going to put 1 penny in the jar. On the 2nd, I will put 2 pennies. Then every day after that, I'm going to double what I put in the jar on the previous day. So how many pennies will I put in the jar on March 31st? Try to think about that and see how far you can get, and we'll expose the answer tomorrow. So let's dive right in, though, to standard notation. And scientific notation. The first ones are written in scientific notation, and we want to undo that just to see just how big these numbers actually are. So in scientific notation, it always looks in this form. It has a number times 10 to some power, either a positive power or a negative power. And for some reason, even in the higher levels of math, this is the one time that we treat the true X multiplication, the cross sign multiplication, as opposed to the dot. And this goes for a lot of higher levels in math, that we still stick with this. So let's go ahead and take a look at how to write things back into standard notation. And there's one phrase that has always helped me with scientific notation, writing it in scientific, out of scientific, anything like that. I've gone through the stages of, well, if I'm writing it in scientific notation and it's this, or if I move things to the right, that means positive, but when I'm taking it out of scientific notation, then moving it to the right means negative, or whatever. And I've never had a lot of success with that. So I kind of came up with another way to think about it. If it's a big number, then it has a positive exponent. And by big number, I mean a number a long ways away from zero. Okay, because we can have very, very, very big negative numbers as well. And even though they're a long ways left on the number line, we kind of think of that as a small, small number. But I'm talking about big in size. Is it a number in the thousands, positive or negative? Or is it a number in the thousandths, a really small decimal? And so if it's a big number, it has a positive exponent, and that goes both ways. If it has a positive exponent, then it's a big number. And the opposite is also true. If it's a small number, a number very close to zero, either positive or negative, then it has a small exponent. Sorry, say a negative exponent. And that can be one key that I think can help you figure out how to write in standard notation, write in scientific notation. Doesn't matter, whether you're going into it or out of it. It can help you out. So a number like this, negative 4.54 times 10 to the third. 3 is a positive exponent, so this is a big number. Now it's a big negative number. We have to accept that. But that means that the decimal is going to make this a big number, a number with commas instead of a decimal and a bunch of zeros. Okay, so the decimal started here. It's going to move 3 places to the right. And I'm going to fill in any gaps with zeros. So this number ends up being negative 4,540. And that to us is a big number. It's a long ways away from zero. Okay. The next one has 10 to the negative 6. Negative exponent, small number. This is a number very, very close to zero. So it starts as, I don't know why I put a 0 there. It starts as 3.6. And I want a very small number. So I'm going to move the decimal to the left 6 times. 3, 4, 5, 6. My decimal is going to move here. I like a leading 0 before the decimal. And I'm going to fill in all the gaps with zeros. Okay. I never like how it looks when I actually move it, so I love to rewrite it, make it a little bit more legible, and I actually count my zeros 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 36. Okay. Next one says to write each number in standard notation. They mean scientific. I mean scientific notation. Okay. So I'm still using that same rule. Big number, positive exponent, small number, negative exponent. This one is a small number, so it's going to have a negative exponent. Let's see how negative. 1, 2, 3, 4. I'm moving the decimal 4 times to be between the first two non-zero numbers. And it's a small number, so negative exponent. In the next one, I have a very, very big number. Now, this number would usually have commas in here. So it's 94,500,000. And the decimal starts right here. If there's commas put in, or if you can put commas in, it makes counting a lot easier because you know that every comma has been 3 places. Okay, so this decimal is going to move 3, 6, 7 places. Whenever we write in standard form, we want the decimal in between the first 2 non-zero numbers. And since it's a big number, it's going to be a positive exponent of 7. So these two are ones that are kind of scientific notation, but they're messed up a little bit because the decimal's not in between the first 2 non-zero numbers. And so we want to fix that. And there are rules here, going along with, well, if you're moving it left, it does this. If you're moving it right, it does this. And I will be completely honest and tell you that those never worked for me. I never was successful thinking that way. So what I ended up doing, and this is just me personally, I switched it into standard notation and then moved it back into scientific notation the right way. And a lot of times I kind of did it. I kind of just thought about doing it and then realized what my exponent had to be. So the problem here, as I kind of mentioned, I want the decimal to be between the 7 and the 5. And so this is 10 to the negative 5th power with it here. And then I never remember, does that make it 10 to the negative 4th? Does that make it 10 to the negative 6th? I know it's going to change this exponent by 1 place, but I don't remember which way. So I'm going to think about moving the decimal. Since this is a negative exponent, this is a very, very small number. I'm going to think about 7, 5, 8 decimals here, and it's going to move 5 places to the left to give me a very, very small number. 1, 2, 3, 4, 5. So it gives me 0.1, 2, 3, 4, 5 zeros, 7, 5, 8. Now I'm going to move it back. And it turns out that a lot of times I kind of quick track this a little bit. Say, yeah, it moved 5 places. It's going to move back 5 places and 1 more. So it's going to move 6 times. And that usually would help me out. and that's going to be times 10 to the negative sixth. Okay, and so really what I did was I would say, okay, this is a positive exponent, so it's a very big number. It's going to move that way 6 times. Then it's going to move back 6 times to get where it started, and then one more. So it's going to be moving 7 times. And since it's a big number, it's a positive exponent. And now that we've dealt with writing in scientific notation, let's look at some operations with scientific notation. The first ones we have are some multiplication problems. And I know at the start I said add and subtract. Adding and subtracting scientific notation isn't that exciting unless you have the same exponent on the 10. Because if I were to think about adding these, this is 280, and this is like negative 0.0049. If I was thinking about adding those, it wouldn't be that exciting. It would be 270.00 something 51, right? So adding and subtracting is relatively boring, but multiplying, raising to a power, and dividing are things that we should be able to do. So when I'm multiplying these, it really turns into problems that we've done before with exponents. It turns into negative 4.9 times 10 to the negative third times 2.8 times 10 to the second. Multiply your numbers and numbers. 4.9 times 2.8, I know it's negative, so I get 13.72. And then I have a product of exponents here. I have 10 to the negative third times 10 to the second. And that would give me negative 3 plus 2, 10 to the negative first power. Okay. Well, that's a small number, right? That's a pretty small number because it's a negative exponent. So from here, it's actually going to move 1 to the left. Okay, that's how I make this number smaller. So the real number, the full number, in standard notation, is 1.372. The reason I'm worried about this is that I want the decimal between the first two non-zero numbers. So that's where I want the decimal. And I don't want to multiply it by anything, but I still need to write it in scientific notation. So it would be like multiplying by 10 to the what power? What power is like not multiplying by anything? Well, basically, I want to turn this 10 into a 1. So it's going to be 10 to the 0 power. And if we are writing in scientific notation, we do still want to have that times 10 to something, even if it's times 10 to the 0. Okay, let's look at the next one. So we've kind of accepted what I want to do is that I want to, this was supposed to be negative. I can just hear getting roasted about that. What I want to do is multiply my numbers and numbers. 3.76 times 8 is 30.08. Exponent-wise, I'm going to add those exponents. 2 plus 2 is 4. 4 is a positive exponent, so this is a big number. It's going to move 4 places that way, 4 places back, and then 1 more to get between the 3 and the 0. Okay, and I know before I said between the first two non-zero numbers, I guess just after the first non-zero number because, yeah, I'm putting it between the 3 and the 0. But what did I say? It moved 4 places that way, 4 places back, and 5 to be 1 more, so that's times 10 to the 5th. The next one, I have 3.5 times 7.29. Yeah. I get 25.515. times 10. 5 plus 3 is 8. It's going to move that way 8 times, move that way back 8 times, and one more to give me a total of 9 decimal point moves. I guess that's 5515 times 10 to the 9th. On the last one here, again, this one's going to be negative. Don't let me forget that. 32, I wish I would have remembered more. 0.9874, sure, or 9784. We can write all those, that's okay. Times 10 to the negative 2 plus 7 is the 5th power. So, positive exponent, big number. Move it that way 5 times, move it that way back 5 times, and one more to get it there. Negative 3.29784 times 10 to the 6th. On the next ones, we're raising scientific notation numbers to a certain power. And so let's see what effect that has. I do my same thing that I've done before with power to a power, where I think about airdropping that 2 in there. And so I have 3.7 to the 2nd power. I'm just going to multiply it by itself. 13.69. And then times 10 to the negative 6 times 2 is negative 12. That's a small number. It's going to move that way 12 times. And then it's not going to move back 12 times. It's going to move back 11 times and stop a little earlier than where it was. 1.369 times 10 to the negative 11th. The next one is 7.8 times 10 to the 5th to the 3rd power. When I multiply that 7.8 by itself 3 times, I get 474,552.552. That is a decimal. And that's times 10. 5 times 3 is the 15th power. And so this is a big number. So the decimal is going to move. This is definitely one that I don't want to actually write in scientific notation. It's going to move that way 15 times, move back 15 times, 16, 17 total. 4.74552 times 10 to the 17th. Oops. This one, I want 5.28. I'm tired of multiplying it by itself over and over again. Raised to the 3rd power is 147. I'm going to go ahead and round this to 0.2. 147.2 times 10 to the 4 times 3 is the 12th power. It's going to move that way 12 times to be a big number, move back to almost be in scientific notation 12 times, 13, 14 total. 1.472 times 10 to the 14th. So that skill of being able to write a number that's almost in scientific notation is something that's coming up a lot. So be prepared for that. Let's see, we've got 4.5 to the 4th. Got to get creative there. That's 400 point, let's call it 410.1. I do want to do a little bit of rounding, so I'm not tired of writing numbers. Times 10, negative 8 times 4 is negative 32. That makes it a small number, so it's going to move that way 32 times. It's going to move back almost 32 times. If it moved 32 times, it would have gone too far. So it's going to move back, call it 29, 30 times. Okay. 30 moves would take it between the 4 and the 1. So 4.101 times 10 to the negative 30. Okay, the last thing that we want to be able to do is to divide numbers in scientific notation. So let's take a look at that. The first one, and so this is what I'm going to do in all these. I'm going to go number divided by number, and then multiply that by power of 10 divided by power of 10. And in this one, I'm actually going to use my subtraction. I know I didn't yesterday all the time, but I'm going to use my quotient rule of subtracting my exponents because I'm okay with negative exponents when it comes to scientific notation. 12 divided by 4 is 3. We can call it 3.0 so that we have a decimal there. 3 minus 5 is negative 2. So this is what I get. And you can always ask yourself, does that make sense? Because 10 to the negative 2 is going to make this a small number. Well, this is, I know it looks like 12 divided by 4, but this is really 12,000 divided by, is it 12,000? Yeah, 12,000 divided by, yeah, I know it, 400,000. So, yeah, that's going to be a small number. Okay, the next one, number divided by number. I'm going to look at 2.25. I know it needs to be a negative, so negative 1.125. And then times 10 to the 2 minus negative 6. 2 minus negative 6 is 2 plus 6, which is 8. So this ends up being a very, very big number, which makes sense because this is a relatively big number. It's negative 225. And this is like a lot of zeros and then a 2. When I take a really big number divided by a really, really small number, my answer is a very, very big number. Sorry. Dividing number by number. Definitely want to round that. Let's call it 2.13. 2.13 times 10 to the 8 minus 5, which is 3. Dividing can be a lot easier because my leading number has less of a chance to get to be a very large number. 3.1 divided by 2.1 make it negative. Okay, I focused on negative and not the number. Let's call it 1.48. Times 10 to the 5 minus 8, which is negative 3. And there we go. Put any questions you have over on the left. Otherwise, I hope you have a great day and we'll see you in class.